Assalamualaikum and hi, welcome to CST Studio Suite. My name is Muhammad Hafzuddin Hamis bin Halim, and my project is modeling and simulate a compact Vivaldi antenna for fault detection in power system. My objective is to model and simulate a compact Vivaldi antenna operating in the 2 to 4 GHz range for fault detection high frequency faults such as partial discharge and arcing. My approach is simulation based project using CST Studio Suite. For this project, I use CST Studio Suite 2024 version. Why I use this tool? A 3D electromagnetic simulation software widely used in antenna design. It allows precise modeling of antenna and helps simulate important parameters such as a return loss, VSWR, and also radiation pattern. I choose CST because of its accuracy, 3D capabilities, and suitability for ultra-wideband antenna design. Like the Vivaldi antenna, which is essential for detection and detecting high-frequency fault signal in power network. It's also suitable for industry standard, and this is suitable for ultra-wideband antenna like Vivaldi, especially in space-constrained power system environment. That's why we create a compact design of the antenna. I designed the compact Vivaldi antenna in CST Studio Suite by focusing on two key areas. First, the exponential taper, which shaped the radiation slot for wideband formant, and then the microstrip feed line. The antenna was simulated at the back, which feeds the signal into the antenna with proper impedance matching for a 2 to 4 GHz. And then how I make this kind of shape, this curve, first is I make the front line at the front of the antenna. I name it line 1, and then the gap between the two curves is I name it is the polygon, which is the center with the feed line, microstrip feed line, and then lastly I name it the analytical curve, which is this is bottom of the curve, the curve, and then analytical 2 is top of curve at the top of the antenna, and then I design the microstrip feed line, which is the height and the thickness of microstrip feed line also crucial for this this design. And then I use the PCB board that using material of FR4 that fire redundant. Then the key results include the return loss S11 of negative 22. So negative 22, this is the best result, negative 22, which means I mentioned in the report it's below negative 10, so I achieved that. And then for VSWR of 1.15, VSWR at 1.16, this is below 2, so meaning minimal signal reflection. And lastly is the directional radiation pattern, so it is suitable for detecting weak fault signal like arcing and partial discharge in noisy environment. This result confirms that the antenna is efficient, compact, and meets the fault detection requirement. So I want to show about the result and how it valid. First of all is the S11, return loss S11. It show for the best result is negative 22.5 or negative 2.2 negative 22.69 dB at 2.55 or 2.56 GHz. This is show the excellent impedance matching that I mentioned in the report. And secondly is VSWR, voltage standing wave ratio. It's get the 1.16 or 1.15. I mentioned in the report in the literature review also. It's meaning it means it get a minimal signal reflection, so it good in the noisy requirement. And lastly is the radiation pattern, directional radiation pattern is focused on fault detection only. Why the simulation in CST show promising results? Real-world factors such as installation condition, electromagnetic interference, or environmental noisy are not fully simulated. However, the project provides a solid foundation for practical fault detection system. The antenna's small size, only 6 multiplied by 4.5 cm, allows easy integration into space limit areas like main switchboard room or substation panels. It's enhancing system monitoring without major modification. In the conclusion, CST Studio Suite allow me to model, simulate, and optimize a compact Vivaldi antenna that meets the performance goals for fault detection in the 2 to 4 GHz range, which means this is the range of partial discharge and arcing faults. Okay, the design achieved low return loss, good VSWR, and directional radiation suitable for detection or detecting fault-related electromagnetic signal in power system. This project bridged communication engineering and power system monitoring, offering a practical solution to enhance reliability and safety. Thank you for your